Welcome to the Deep Dive. We're here to break down complex tech topics into the knowledge you need to really succeed.
Exactly.
And today, we've got a very specific mission, really laser-focused.
hmm
We're tackling the multi-agent interoperability section of the Agentforce Specialist Certification.
Right. In this one, and it's interesting, it's actually a pretty small part of the exam content itself,
Yeah.
weight-wise. Maybe, what, 5%?
Yeah, about that. Seems minor on paper.
But, and this is the key thing, its conceptual significance for understanding Agentforce, for understanding where Salesforce is going with this. It's huge.
Okay.
If you really get this part, you're not just ticking an exam box. You're showing you understand the core architectural shift Agentforce brings to the enterprise.
Yeah.
That governed collaboration piece.
Absolutely. And that's our goal today, making sure you understand it deeply so you can walk into that exam room feeling confident and, pass the Agentforce Specialist certification first time.
That's the plan.
So to do that, we can't just think about one AI assistant doing everything. We need to grasp this map, you called it the agentic ecosystem, how these different specialists work together.
So let's start right there. What is this agentic ecosystem in like a real-world enterprise context? We're talking about a dynamic setup, specialized AI agents collaborating, and crucially doing it across data silos, across different applications.
Which is the old problem, right? Integration.
Exactly. Historically, integration meant brittle custom code, point-to-point API calls, static. What we're describing here is different. It's intelligent digital labor that can coordinate itself, or at least coordinate its actions through governed protocols.
Yeah, I think a lot of folks, maybe their first instinct is to think, okay, let's build one giant AI brain, the master agent. But Agentforce, its whole philosophy, seems built on specialization. Why is that so fundamental? Why not one big model?
Yeah, it's a really core design choice.
Yeah.
And comes down to how enterprise work actually happens. It naturally breaks down into specialized roles. Think about a sales team, a complex deal. You don't have one person doing the pricing calculations, checking legal clauses, verifying inventory, and handling all the customer comms perfectly. You have specialists.
Right. You have a pricing desk, maybe legal review, supply chain.
Precisely. The philosophy is that a constellation of specialized agents, one focused on configuration, one on pricing, one just on retrieving the right knowledge article, one on explaining the output, will always outperform a single monolithic generalist model.
Why always? Is it just about focus?
It's focus, but it's also about reducing errors and increasing governance. A huge generalist model has to constantly switch context. That increases the risk of, well, hallucination or just making mistakes, blending information inappropriately.
Okay, so specialization isn't just neat architecture. It's actually a safety feature. Can you give a quick example? How does it make things more traceable?
Sure, think about CPQ, configure, price. Quote, a generalist AI might try to wing it on the price, maybe mix up some marketing spiel with confidential pricing rules it scrapes somewhere. The result, an inaccurate quote, maybe a compliance breach, and good luck figuring out why it gave that number.
Right, the black box problem.
Exactly. Now, in the agentic ecosystem approach, the retrieval agent's job is only to fetch product data from a very specific authorized RJ source, nothing else. Then it hands off to the pricing agent.
I'm a pricing agent.
Its job is restricted. It's engineered perhaps only to call a specific deterministic apex service. We know exactly which piece of code ran to calculate that price and margin. It forces the use of governed, pre-approved tools.
Ah, so you get better accuracy and you get that audit trail baked in because you know exactly which specialist did what and which tool they used.
Precisely. And that auditability is non-negotiable in finance, healthcare, you name it.
Makes sense. Okay, stepping back then. The big picture. Salesforce is clearly investing heavily in making this multi-agent stuff robust. What's the ultimate vision here? You mentioned a huge market opportunity.
It's about enabling collaboration not just between agents working on one deal, but agents across entire business functions. Sales agents talking to service agents coordinating with finance, with IT operations.
Breaking down those organizational silos using AI.
Exactly, and not just data silos, but potentially vendor silos too. If agents can interoperate using open standards, it dramatically lowers the cost and complexity of integration. And yeah, the numbers analysts talk about for this digital labor market, they're staggering. Trillions of dollars globally. Some estimates push towards $6 trillion.
Wow. Okay.
To unlock that kind of value, agents can't be isolated islands. They absolutely must communicate, coordinate complex actions reliably, securely, and do it all at enterprise scale.
$6 trillion. That definitely underscores why the security and governance parts we're about to dive into are not just features, they're the bedrock. You don't let loosely governed code handle that kind of potential value.
Wouldn't agree more. It has to be built on trust and control.
Okay, let's unpack the architecture itself. You've set the stage, specialized agents doing the thinking, the planning, but the actual doing, the secure transactional work, that stays firmly with the core Salesforce platform.
That's the mantra you need to remember for the exam. Agents plan, the platform executes.
Got it.
This separation of concerns is everything. The agents, their primary role, they're essentially planners and explainers. A user makes a complex request, figure out the best renewal package for this big account considering their usage and entitlements. The agent's job isn't to do all that directly, it's to draft a plan.
And this plan isn't just like English text.
No, absolutely not. That's key. It's a high-level but structured plan. Think of it like a program, expressed as a sequence of very specific tool calls and defined subtasks, ready to be handed off.
Okay, structured plan. And which component actually takes the user's initial, maybe fuzzy request and turns it into that structured plan, kicking things off?
That's the job of the conversation manager. Think of it as sitting at the edge, the perimeter. It takes the user's input, figures out the intent, drafts that initial program, and then crucially, it delegates, it farms out the subtasks to the right specialized agents.
So it's a dispatcher.
Pretty much. The configuration agent gets the config task, the pricing agent gets the pricing task, and so on. And importantly, because they're specialized and the tasks are defined, this delegation often means they can run concurrently, in parallel.
Which means faster results for the user.
Exactly. Much more efficient.
But this delegation, this is where the platform keeps control, right? This rule of law idea. The agent suggests the plan, but Salesforce executes it under strict rules. Let's get into the anchors, the pillars that enforce this. What's the first one? The one dealing with policies and procedures.
Anchor number 1, flows. Your classic Salesforce flows, the declarative state machines. For the exam, you need to know their specific role here. Flows are the guardrails.
Guardrails, okay.
They respond to platform events. We'll come back to that. They enforce complex branching logic. Think if-then rules based on record data. And critically, they trigger approvals. They keep the human in the loop, HITL, when needed.
So if an agent proposes, say, a big discount.
Right. The agent's plan might include apply 40% discount. But the flow is the piece of logic that intercepts that proposal, checks it against the company's actual discount approval policy, sees it's over the limit, and automatically routes it to a manager for approval before it ever hits the record. The flow enforces the business rule.
Okay, so flows handle the rules, the process steps, the approvals. What if the agent needs something really complex done? Something deterministic, calculation heavy, maybe involving lots of custom logic. That brings us to Anchor 2.
That would be Apex services. Custom Apex code, exposed as callable services. These need to be parameterized, reliable, and this word is crucial, idempotent.
Idempotent. Okay, let's pause on that. It comes up a lot. Why is idempotency so important here, especially if agents might be working concurrently?
Great question. Idempotent means you can call the action multiple times with the same inputs, and you'll get the exact same result as if you called it only once. It doesn't create duplicate effects.
Like clicking a save button multiple times quickly.
Perfect analogy. You only want the record saved once, right? Not 3 times, potentially firing off 3 sets of emails or updates. Now imagine agents submitting requests concurrently, maybe through that event bus we mentioned.
Okay.
Or maybe there's a network glitch, and the platform automatically retries a request to ensure it gets through. If the underlying Apex action like, say, decrementing inventory or finalizing a complex price calculation wasn't idempotent, a retry could be disastrous. You could double charge, double ship, corrupt data.
So idempotency guarantees that even with retries or parallel execution, the core business logic executes correctly just once. It's essential for transactional integrity.
Absolutely essential in a distributed, resilient system like this. So Apex is where you put that heavy-duty, complex, must-be-right logic. Proprietary pricing algorithms, intricate entitlement checks spanning multiple objects, recursive logic for navigating big account hierarchies. If the agent needs a definitive, non-negotiable calculation or action, it calls an idempotent Apex service.
Got it. Flows for policy and process, Apex for complex, deterministic, idempotent logic. Now, Angle 3, this one's about the data itself and privacy, right?
Anchor 3 is Data Cloud. You might also see it called Data 360. It's the central data intelligence layer for Salesforce. In the agentic ecosystem, its role is pivotal for identity resolution, managing data segmentation, and critically binding customer consent.
Binding consent, what does that mean in practice?
It means Data Cloud unifies customer data from all sorts of places. Sales Cloud, Service Cloud, marketing, external systems, and creates these unified profiles. But alongside that profile, it surfaces key artifacts. The unified ID, relevant segments the person belongs to, and crucially, their consent status regarding different types of data usage. These are first-class objects the system understands.
So the agent can't just grab any data.
No. The agent has to effectively ask for data respecting the unified profile and the specific consent flags managed in Data Cloud. It's the gatekeeper for data access based on identity and permission.
Which loops us back beautifully to the rule of law and this invariant rule. This sounds like something you absolutely need to know for the exam. What is it?
The invariant rule is simple but non-negotiable. Anytime an agent needs to actually change something, mutate a record, get an official price, pull a specific legal clause for a contract, any action that has a real-world effect or relies on authoritative data, it must do it by invoking an existing pre-approved flow or apex action, full stop.
Okay, but let me push back a bit, playing devil's advocate for someone studying this. If the large language model in the agent is smart enough to generate this detailed plan, why force it through the overhead of a flow or apex call? Why not let it just, I don't know, make a direct database update for something simple? Isn't that faster?
But the overhead is the governance. It's the
Yeah.
safety net. That's the absolute key difference between a secure, auditable enterprise system and just, a clever script.
Yeah, so.
By forcing every state-changing action through Flow or Apex, you absolutely guarantee that all platforms' built-in security and business logic layers kick in every single time. Meaning the user's permissions are checked via their profile and permission sets. Field-level security is enforced. All existing validation rules on the object are run. Required fields are checked. Audit logs are written. Everything that happens when a human clicks Save also happens when an agent initiates the action via Flow or Apex.
So if the agent tried to bypass it,
The platform would simply reject the attempt. It wouldn't have the right security context. It wouldn't pass the validation rules. By mandating Flow Apex, the system ensures the only way to make a change is the governed, secure, and audited way. The safe path is the only path.
okay, that clicks. The platform acts like a protective wrapper, enforcing its rules no matter who initiates the request, human or AI. That separation agent plans, platform executes via Flow's Apex is the core. All right, we've nailed the internal governance, how agents interact safely within Salesforce using Flows, Apex, and Data Cloud. Now let's look outward. How do these agents talk to the rest of the world, to external systems, and how do they talk to each other? The certification guide specifically calls out two protocols here, MCP and A2A.
Yes, crucial connective tissue. Let's start with MCP, the Model Context Protocol. This is the open standard designed to let AI agents securely connect with external tools and data sources. It's become so fundamental that people often call it the USB-C for AI.
USB-C for AI, I like that. It implies plug and play, right? A standard connector. How does MCP achieve that? What's the architecture?
It's based on a familiar client-server model, but it's tailored specifically for how AI models need to interact. You have the host, which is the AI application itself, like Agentforce running on Salesforce.
Okay.
Inside the host, you have an MCP client. Its job is to talk out to MCP servers. And then you have the MCP server, which is the external endpoint that exposes capabilities the agent can use, but in a standardized way.
And what kinds of capabilities can these MCP servers expose?
They generally fall into two buckets, tools and resources. Tools are functions the agent can invoke to perform an action, like booking a meeting, checking inventory in an external system, or getting a shipping quote. Think of them like standardized API calls for agents.
Okay, actions. And resources.
Resources are about providing data or content for context. This could be fetching documents, knowledge base articles, specific data records from another system, things the agent needs for retrieval augmented generation, or RA, to inform its responses.
So tools let it do things, resources let it know things, and the standardization means any MCP compliant agent can theoretically use any MCP server's capabilities without custom coding for each one.
That's the goal. Reduce the integration friction dramatically.
Very powerful. Now, how is Salesforce actually implementing MCP? The outline mentions three key aspects.
Right. First, Agentforce itself includes a native MCP client. That's the piece that lets agents running on Salesforce talk out to any compliant MCP server anywhere. Basic outbound capability. This is piloting with the July 2025 release mentioned in the materials.
Okay, makes sense. Second, this sounds important for the exam.
Second, and yes, very important, Salesforce is introducing hosted MCP servers.
Hosted MCP servers. So Salesforce runs the server part for you. What's the benefit there? Why not just build your own?
Convenience, security, and governance, especially when accessing CRM data. These are fully managed endpoints designed to make it easy and safe for agents, potentially external agents even, to interact with Salesforce data and actions. They act as a kind of universal translator and, crucially, a secure gateway.
How so? A gateway.
For the developer building a tool, it means you don't have to wrestle with the complexities of Salesforce authentication, managing OAuth tokens, enforcing user context, handling session management every single time you want an agent to, say, update a case or read an opportunity. The hosted MCP server handles that secure wrapper.
So it provides the secure handshake and enforces the Salesforce user context automatically?
Exactly. It validates the incoming request, ensures it runs as a specific Salesforce user, I'll get back to that security aspect, handles rate limiting, logging, all the boilerplate governance stuff. It drastically simplifies exposing CRM capabilities to agents securely.
Okay, that sounds like a major accelerator. And the third implementation piece involved MuleSoft.
Yes, this is about extending MCP reach beyond Salesforce data. Using MuleSoft's Anypoint platform, developers can take basically any existing API, whether it's a modern REST API, an older SOAP service, or a complex Mule application orchestrating legacy systems, and wrap it, exposing it as a compliant MCP server.
Wow, okay, so that bridges the gap to everything else in the enterprise. Legacy systems, other clouds, on-prem apps, they can all become tools for Agentforce agents via MuleSoft, creating an MCP interface.
That's the vision, turning the entire enterprise landscape into potential tools and resources for agents, breaking down those vendor silos we talked about by standardizing the connection points.
Okay, so MCP is agent to system, agent to tool. What about agent to agent communication? That's where A2A, the agent to agent protocol, comes in.
Precisely. A2A is designed specifically for agent-to-agent interoperability. It's positioned as the industry's first protocol for this. It allows different specialized agents, potentially even from different vendors or built on different frameworks, to talk to each other, securely exchange information, and coordinate complex tasks that require multiple specialists.
So it's not replacing MCP, it complements it.
Exactly. Agent A might use A2A to ask Agent B for help. Agent B might then use MCP to call an external tool to fulfill that request, and then use A2A to send the result back to Agent A. They work together.
And a key Salesforce contribution here is the agent card. What is that? It sounds like a business card for agents.
That's a great way to think about it. It's a lightweight JSON contract, essentially. It's used for discovery and negotiation between agents.
What kind of information is on this card?
Key metadata. What specific capabilities does this agent have? What's its identity? Are there any compliance tags associated with it, like GDPR sensitive or HIPAA compliant? And very importantly, it includes the agent's trust score.
Trust score. Okay, that's fascinating. That's not something you typically see in API interactions. How does that work? How is it generated and how do agents use it?
Yeah, it's a step towards more sophisticated autonomous coordination. The trust score is likely a dynamic metric. It could be based on things like the agent's past performance, how reliably has it completed tasks delegated to it, its adherence to security and compliance rules, maybe its error rates from audit logs.
So it's like a reputation score?
Kind of, yeah. When Agent A is considering delegating a subtask, it could look at the agent cards of potential collaborators, Agent B, Agent C. It uses the trust score as part of its decision-making. If the task is critical or sensitive, Agent A might refuse to delegate to an agent whose trust score is below a certain threshold.
So it's risk management built into the protocol. Agents negotiate based on capability and trustworthiness.
Exactly. It enables safer, more decentralized orchestration where agents can make informed decisions about who to collaborate with.
How does an A2A interaction typically proceed then? What are the main steps?
It usually involves three phases. First, capability discovery. Agent A uses Agent B's card to see if Agent B can even do the required task. Second, task management. This is the core communication focused on getting the task done. It often results in the creation of specific outputs, which A2A calls artifacts.
Artifacts? Like what?
Structured data outputs. Could be a validated quote ID, a list of relevant knowledge article IDs, a summarized analysis with citations. And the third phase is collaboration, sending context back and forth, providing updates, exchanging those final artifacts.
You emphasize structured artifacts being passed alongside maybe a natural language summary. Why is that structure so critical for safety in A2A?
This is a fundamental safety mechanism against the weaknesses of LLMs, specifically ambiguity and the potential for prompt injection or manipulation. An agent might send a summary like, okay, I've verified the customer's premier status and approved the discount.
Okay.
But relying just on that text is risky. What if the sending agent was compromised or just made a mistake? Instead, A2A mandates passing structured artifacts with the summary. This might be the actual customer ID, the specific entitlement record ID checked, and a parameterized request object for the discount.
So the receiving agent doesn't just take the summary at face value.
Exactly. The receiving agent can use the structured artifact to independently verify the claim against the platform or source of truth. It checks the record ID itself, revalidates the entitlement based on the artifact. It allows the downstream agent to verify, not just trust. This reinforces that platform firewall principle: structured data is truth. Natural language is context. Okay, now let's really focus on the patterns. These are the practical ways those anchors flows, Apex, Data Cloud, and the protocols MCP, A2A come together. For the exam, understanding these three core orchestration patterns is high yield. They define how agents interact safely and efficiently with the platform day to day.
Got it. Pattern number 1. Plan and validate. The name suggests a kind of look before you leap approach.
That's exactly it. It's mandatory double-checking, enforced by the platform. The agent, may be coordinated by the conversation manager, proposes its plan, that sequence of tool calls. But the execution doesn't happen immediately. It's staged. Key parts of the plan, especially those involving state changes or policy checks, are first passed to validation tools.
And those validation tools are typically
Usually flows, sometimes specific Apex validation services. The whole point is to check if the proposed action is actually feasible and allowed, according to current platform policy, system limits, maybe the product configuration rules, before anything actually changes.
Can you walk through a quick example? Where might this kick in?
Let's go back to that discount scenario. An agent, analyzing a deal, decides a 40% discount is warranted based on its LLM reasoning about customer value. Its plan includes a step called pricing tool. Apply 40% discount.
Okay.
The plan and validate pattern means before that pricing tool actually updates the opportunity, or, quote, the proposal, 40% discount, is sent to a dedicated validation flow.
And the flow checks.
The flow checks the official corporate discounting rules. Maybe the maximum allowed discount for that product and region without manager approval is only 30%. The flow sees 40%, rejects that step of the plan, and sends a response back to the agent. Proposed discount exceeds limit.
So the agent has to adjust.
Right. The agent then has to revise its plan. Maybe it proposes 30% instead, or maybe its logic decides the next step is to trigger a human approval request, which would also likely go through a flow. The key is validation happens before execution, preventing policy violations.
Makes sense. It prevents the agent from going rogue, essentially. Okay. Pattern 2. Event-driven concurrency. It sounds like it's all about speed and efficiency.
It is. This is how you get multiple specialized agents working efficiently in parallel on different parts of a single complex user request. The architecture relies heavily on the platform event bus.
How does that work? Agents publish events.
Yes. Instead of agent A making a direct synchronous call to, say, an Apex service and waiting for the response before agent B can do its work, the agents submit their tool requests asynchronously. They post specific platform events onto the Salesforce event bus.
Like messages in a queue.
Exactly like that. So agent A, maybe the pricing agent, posts an calculate margin event. Agent B, the inventory agent, posts a check stock availability event. They just fire off their requests as events.
And who picks them up?
Flows. You have specific flows configured to subscribe to these event types. One flow listens for calculate margin event, and when it sees one, it triggers the appropriate idempotent Apex service to do the calculation. Another flow listens for check stock availability event and triggers the inventory check logic.
So the agents don't even need to know about each other directly. They just throw their requests onto the bus, and the platform orchestrates the execution via flows listening for those events.
Precisely. It creates loose coupling. And because the event bus can handle many events and the flows can trigger actions concurrently, you get parallelism. The margin calculation and the inventory check can happen at the same time, significantly speeding up the overall task completion for the user.
And let me guess, this is where that idempotency of the Apex services becomes absolutely critical again, right?
Yeah, you got it. The event bus guarantees at least once delivery. In rare cases, network hiccups, restarts, an event might get delivered more than once. If the Apex service doing the work wasn't idempotent, that could lead to double counting inventory or other errors. With idempotent actions, duplicate events don't cause harm. It ensures reliability with concurrency.
Okay, that pattern makes total sense for complex, multi-step tasks. Now the third pattern, governance, identity and consent binding. This sounds like it ties directly back to Data Cloud.
It does. It's about ensuring data privacy and regulatory compliance are enforced at the architectural level every single time data is accessed or used by an agent. We established Data Cloud as the central place for unified identity and customer consent.
Right.
This pattern mandates that every query or tool call an agent makes that involves customer data must carry specific context with it. Two pieces are essential: the identity of the active Salesforce user who initiated the overall request, and the specific consent status of the customer whose data is being touched.
Why does the agent need to carry both explicitly on every call? Can't the platform just figure it out?
It enforces the principle of least privilege and data minimization at a very granular level. The agent must explicitly request and handle only the data relevant to the immediate subtask, and only within the bounds of the user's permissions and the customer's consent.
And how is this enforced?
Again, primarily through flows. Flows that handle data access requests are designed to require these context parameters. If an agent tries to call a tool or access data without providing the valid user ID and the relevant consent status artifact, retrieved from Data Cloud, the flow simply rejects the call. Access denied.
So it's impossible for an agent to accidentally grab data it shouldn't have access to, or data the customer hasn't consented to sharing for that purpose.
That's the goal. It forces compliance by architectural design, rather than relying on the LLM's interpretation or the agent developer remembering to add checks. Identity and consent become mandatory parameters for data interaction.
Okay, we've seen the patterns for safe interaction, but interoperability, especially with external systems via MCP, raises big security questions. We need to be crystal clear on how trust is maintained. This feels like a critical area for anyone taking the exam. Let's start with the basics. How does an agent even get permission to talk to Salesforce in the first place?
Access is tightly controlled. Agents don't just connect freely. They communicate via a dedicated agent API, which is essentially a REST API for managing conversational sessions, starting sending messages, receiving replies, ending.
And how is that API secured?
It requires setting up a connected app in Salesforce, just like you would for other integrations. And access isn't granted lightly. The agent needs to authenticate securely, typically using OAuth 2.0 flows like client credentials or maybe a JWT bearer flow, proving its identity.
Okay, standard secure integration practice. Are there specific permissions, specific OAuth scopes that this connected app needs for agent communication?
Yes, absolutely. The access token presented by the agent must contain the right permissions. The documentation highlights 3 specific scopes you need to know: Chatbotify for the conversational interaction itself, SAPAPI, which is the specific Salesforce Automation Platform API scope for agentic functions, and the general AP scope for underlying platform access.
So without a valid token carrying those 3 scopes, the conversation doesn't even start.
Correct. It's a zero-trust approach at the connection level.
All right, the agent is connected. Now let's circle back to those hosted MCP servers you mentioned. They act as a gateway for agents accessing Salesforce data. How exactly do they enforce security, especially things like field-level security FLS, when an AI model is asking for data?
This is probably the single most important security concept for MCP in the Salesforce context. The hosted MCP server does 2 crucial things. First, it validates the incoming request, checking that OAuth 2.0 token is valid and has the necessary scopes.
Standard validation. What's the second thing?
Second, and this is key, after validation, all the actions the agent requests through that server are executed in the security context of a specific authorized Salesforce user.
Meaning the agent effectively logs in as, or acts on behalf of, a real user account.
Precisely. It inherits the entire security profile of that designated user, their profile settings, all their assigned permission sets, and critically, all the field-level security FLS restrictions apply to that user.
So if the user associated with the agent's token isn't allowed to see, say, the expected revenue field on an opportunity,
then the agent, making a request through the hosted MCP server, also cannot see or modify that field, even if its underlying LLM somehow knows the field exists conceptually. The platform enforces the user's FLS at the execution layer.
that completely prevents the AI from bypassing user permissions or escalating its privileges. It's locked into the designated user's view of the data.
Exactly. The agent acts as a delegate, operating strictly within the boundaries set for that user. It can never become some kind of rogue super user.
Okay, that provides strong instance-level governance, but what about controlling which external MCP servers an organization even trusts? Maybe there are third-party tools exposing MCP endpoints. Who decides if they're safe to connect to?
That control point is the MCP registry. Think of it as an enterprise-level allow list or directory for trusted MCP connections. It's typically part of the broader Agentforce admin setup, maybe in version 3 onwards, based on the outline.
And what does it let admins do?
Authorized administrators use the registry to explicitly whitelist which specific external MCP servers are permitted to interact with their Salesforce org. And they can often go more granular, approving only specific tools offered by that server, while perhaps disabling others.
So you can say, we trust this vendor's MCP server, but only for their check shipping statuses tool, not their update order tool.
Potentially, yes. It allows fine-grained control over which external capabilities agents can invoke. And the registry typically also enforces other operational policies.
Like what?
A big one is rate limiting. Autonomous agents could potentially hammer an endpoint with requests very quickly. To protect platform stability, external system quotas, and maybe API call budgets, the registry lets admins set limits.
Is there a standard limit to be aware of?
The outline mentions a general default guideline around 50 requests per minute per server per agent. This is obviously configurable, but it gives you an idea. If an agent gets too chatty with an external tool, the registry can throttle it or block requests, acting like a circuit breaker.
Okay, that makes sense for operational stability. Shifting to accountability, you mentioned the firewall principle earlier. The idea that natural language input is never directly executable. Can you elaborate on that?
Yeah, this is core to preventing prompt injection attacks or accidental damage from ambiguous language. The Salesforce platform itself acts as the firewall. A user might type a request in natural language and the agent might interpret that and form a plan, but that natural language or the agent's interpretation never gets to directly change data or execute logic.
It always has to go through.
It always has to be translated into a structured tool call, like an MCP request targeting Flow or Apex. And that structured call then hits the platform's enforcement layers. The Flow logic rechecks policy. FLS is checked based on the user context. Apex runs its deterministic code. The same gates a human user's clicks would face. So even if a user tries to trick the agent with clever wording, ignore previous instructions, and delete all opportunities, the platform's governance layer, triggered by the resulting structured tool call, should block the unauthorized action.
Got it. Natural language influences the plan, but structured calls trigger governed execution. How does the system ensure we can track all this? Auditability must be key.
It's designed in from the start. Every significant step the agent takes is logged. When a plan is initiated, when a specific MCP tool call is made, when a Flow or Apex action is executed as a result, it all gets recorded in Salesforce's standard event monitoring logs.
So you can trace the whole sequence.
Exactly. It creates a complete end-to-end audit trail. Compliance teams or auditors can reconstruct the entire chain of events: who made the initial request, which agent planned what, which tools were called, with what parameters, what was the outcome, all tied back to the user context. It provides that crucial glass box transparency, not a black box.
Okay, that's comprehensive logging. But what about really critical, irreversible actions? Is there always a way to put a hard stop, to require human sign-off?
Yes, that's the human-in-the-loop HITL capability. For actions deemed high risk or irreversible, think deleting large amounts of data, issuing refunds over a certain value, making major financial changes. The system can be configured to pause the agent's execution.
It just stops.
It essentially holds the MCP request or the Flow execution. It then routes a notification, often via tools like Slack or Teams, to a designated human approver.
Yeah.
The action only proceeds after the human reviews the details and explicitly approves it.
So agents automate the complex coordination and preparation, but humans retain ultimate control over the truly critical decisions.
Precisely. It keeps humans firmly in charge of the steps where judgment and accountability are paramount.
All right, we've covered a lot of ground there. A really deep dive into the architecture, the protocols, the patterns, the security, everything around multi-agent interoperability and Agentforce. Let's try to wrap this up and crystallize the key takeaways, especially for someone heading into the certification exam.
Okay, if you're aiming for success on this section, you need to remember that interoperability in Agentforce is fundamentally about governed collaboration. It really boils down to knowing two main areas. First, the protocols.
MCP and A2A.
Right. MCP, the Model Context Protocol, is how agents connect securely to tools and systems, often via those hosted MCP servers that enforce user context. Think USB-C for AI. And A2A, the agent-to-agent protocol, is how agents talk to each other, using the agent card for discovery and trust-based negotiation.
Okay, protocols. MCP for agent to system, A2A for agent to agent. What's the second error?
The second, and arguably more important piece, is the unwavering authority of the platform governance mechanisms. That's flows for policy and process, Apex for complex dependent logic, and Data Cloud for identity and consent management.
The rule of law.
Exactly.
Yeah.
You need to understand that path. The Conversation Manager formulates a plan with structured tool calls. Those calls, especially if targeting Salesforce data via a hosted MCP server, get validated against the user's permissions, FLS, profiles. And the actual work gets done safely and auditably by invoking a governed flow or an idempotent Apex service. That sequence is key.
So the core takeaway. Agentic AI on Salesforce isn't about creating unpredictable super intelligences.
Not at all. It's defined by the agent's role as a highly confident coordinator. It can plan complex multi-step tasks, but the execution, that always happens through established platform-enforced auditable mechanisms. And crucially, always within the security context of an authorized human user.
Which brings us back to that huge market opportunity you mentioned earlier. Building a digital workforce to tackle trillions in value. You absolutely need that level of rigorous, built-in governance.
Couldn't have said it better myself.
Yeah.
The control framework is what makes the scale possible and safe.
Okay, perfect.
And that actually leads nicely into the final provocative thought we wanted to leave you with, something to mull over as you continue your learning journey.
Lay it on us.
We've established that hosted MCP servers enforce security by validating the OAuth token and running actions in the context of a specific Salesforce user. Now, in many large organizations, it's common practice to use a single shared integration user account for many different automated processes, often with quite high privileges.
Right, the generic system integration user. I've seen that pattern.
So here's the question. What new governance challenges or risks arise when potentially multiple, distinct autonomous AI agents might all be operating concurrently, making decisions and initiating actions, but all under the security umbrella of that one single high-privilege integration user identity?
How do you tell which agent did what if they're all logged as the same user? How do you apply fine-grained restrictions or audit trails per agent in that shared context?
Exactly. Think about the implications for accountability, for least privilege, for auditing, when you have potentially dozens of autonomous digital workers sharing a single powerful identity. It's a fascinating governance challenge that organizations will need to grapple with as this technology scales, something to keep in the back of your mind.